Good afternoon, everyone. Myself, Monica Nancy Priya, Assistant Professor from Department of Electrical and Electronics Engineering of Sri Muthukumaran Institute of Technology. Uh, in this presentation, we are going to discuss about the topic transformer, the subject of fundamentals of electrical and electronics engineering. It's a core subject that introduces the basic principle governing electrical and electronic systems. The subject explains how electrical energy is generated, transmitted, controlled, and utilized. It forms the foundation for understanding electrical machines, power systems, power electronics, and control engineering. The course objective of this subject is this. The objective of this course is not only to learn definitions but also to develop analytical thinking. Students will learn how electrical quantities such as voltage, current, power, flux, and frequencies are related. This course helps students understand safety, efficiency, and reliability in electrical installation and systems, and also understand and analyze the DC circuits by applying basic electrical laws such as Ohm's law, Kirchhoff's law, and evaluate the behavior of resistive, inductive, and capacitive components in series and parallel circuits, and also understand domestic wiring systems by identifying different wiring methods, types of cables, earthing systems, protective devices like fuses, HR fuses, and the properties of conducting and insulating materials. Why we study this course, why we are having this syllabus in this modern life depends entirely on electricity. From lighting and fans to industries and communication system, electrical energy plays a major role. This course enable student to understand how electricity is safely converted and controlled. It also prepares students for practical work, laboratory experiments, and industrial applications. The next one is the chapters in the fundamentals of electrical and electronics engineering. In Unit 1, we are having DC circuits and AC circuits. In this, the DC and AC circuit analysis helps us to understand how current, voltage, and power behave in electrical systems such as household appliances, machines, and industrial equipment. And in second unit, we are having magnetic circuits. In this magnetic circuits, it's a backbone of transformers, motors, generators, and inductors, which are widely used in power and industrial applications. While in third unit is basics of power systems. In this unit, we have a knowledge of power system helps students understand how electricity is generated from different sources. Different sources means the hydro, thermal, nuclear, wind, solar, and safely delivered to the consumers. In this fourth unit, we are having domestic wiring. This is very interesting topic. Unit studying wiring methods, earthing, cables, and protective devices helps ensure electrical safety in homes and buildings. Whereas in fifth unit, we are having analog and digital electronics. In this unit, we are going to study about the basics of diodes, transistors, logic gates, and flip-flops provide the foundation for modern electronics communication system, computers, and automation. The next one is now the topic transformer. What is transformer? A transformer is a static device that transfers AC power from one circuit to the another using electromagnetic induction. It allows voltage conversion, which is necessary to reduce transmission losses. Without transformers, long distance power transmission would be uneconomical and inefficient. This is the transformer circuit diagram. In this, the transformer consists of two electrically isolated windings placed on a common magnetic core. The core ensures the most of the magnetic flux produced by the primary winding links the secondary winding. The electrical isolation improves safety and noise reduction. The next one is the part of the transformer. The windings are made of copper or aluminum conductors to reduce the resistance. It is having a primary winding, secondary winding, and core. What is the primary winding? The winding in which the input voltage or AC supply is given is called the primary winding. What is secondary winding? The winding from which where the output is taken. Where the input is given, it's a primary winding. Where the output is taken, That is the output voltage taken. That is the secondary winding. Then core. It's in the center part. It is only the magnetically coupled the primary and secondary winding. In this core, the two windings are wound on an iron core. The iron core is laminated and insulated with varnish. The next one is the principle of transformer. In this, what is the principle for the transformer working? What is the principle? It means the transformer works based on the mutual inductance when two coils influence each other magnetically. According to the Faraday's law, EMF is induced whenever there is a rate of change of magnetic flux. If there is any rate of change of magnetic flux in that part, in that time, the EMF is induced according to the Faraday's law. This principle allows energy transfer without mechanical motion. In that, depending upon that Faraday's law of electromagnetic induction, we are having the formula EMF induced E is equals to M di by dt. Di is nothing but the rate of change of current with respect to rate of change of time. Next is the working of transformer. When AC voltage is applied to the primary winding, it draws a magnetizing current. This current produces an alternating magnetic flux in the iron core. The magnetic flux continuously expands and collapses due to alternating nature of the supply. This alternating flux links both the primary and secondary windings. According to the Faraday's law of electromagnetic induction, this change in flux induces EMF in both the windings. The induced EMF in the primary winding opposes the applied voltage, while the EMF induced in the secondary winding appears across its terminal. When a load is connected to the secondary, current flows through the load. The power is transferred from the primary to the secondary through the magnetic flux. Through the magnetic field, the EMF is induced. Thus, the transformer transfers energy without direct electrical connection, maintaining constant frequency and high efficiency without having electrical connection. This is only depend upon the magnetic, that is magnetically induced because of this iron core. In this, we are having the EMF induced in the primary side. E1 is equals to minus N1. N1 is nothing but the number of turns in the primary side. So it is denoted as a N1. d phi by dt. Phi is nothing but the flux. So rate of change of flux with respect to the rate of change of time. And E2, EMF induced in the secondary side, is nothing but N2. N2 is nothing but the number of turns in the secondary winding. Then d phi by dt. Phi is nothing but the rate of change of flux with respect to time. Next one is the type of transformer. What are the types of transformer? How many types of transformer we are having? We are having the two types of transformer. One is step up transformer and the another one is step down transformer. If the secondary voltage, the secondary winding is higher than the primary winding, primary voltage, then the transformer is said to be the step-up transformer because the secondary winding, the load is connected. So in this load, where the load is connected, the secondary side, the winding is higher than the primary side. So it is said to be a step-up transformer. Then step-down transformer. What is step-down? If the secondary voltage is lower than the primary voltage, whereas the secondary winding is lower than the primary winding, then the transformer is said to be as a step down transformer. Then losses in transformer. What is loss? Losses in a transformer reduces its efficiency. This is a common definition for loss. In here, there is a hysteresis loss occurs due to repeated magnetization and demagnetization of the core. The eddy current, second one is eddy current loss. Eddy current loss occurs due to circulating currents induced in the core. Third one is copper loss. It is depend upon the square of the current and vary with load. Minimizing losses, we have to minimize the losses. So if, what we are doing, if we are minimizing the losses, it increases the efficiency and also the service life. Next is EMF equation. In this, the EMF equation explains how voltage is induced in a transformer. It shows that the induced EMF is directly proportional to the frequency maximum flux, and the number of turns. This equation is fundamental in designing transformer for different voltage levels and frequencies. The next one is voltage transformation ratio. Now, what is meant by voltage transformation ratio? The voltage transformation ratio helps to determine whether the transformer is step up or step down. Since power remains approximately constant, an increase in voltage results in a decrease in the current. This principle ensures efficient power transmission with reduced losses. In this, we are having this voltage transformer is denoted as K. So the supply voltage V1 is equals to induced EMF E1. Supply voltage V2 is equals to the induced EMF E2. So V1 I1 is equals to V2 I2. So the voltage transformation ratio K is equals to V2 divided by V1 equal to E2 divided by E1 is equals to number of turns in secondary to the number of turns in the primary is equal to the current in the primary ratio of the to the current in the secondary. Last, the application of transformer. Where the transformers are used in the real time. It means the transformers are widely used in power generation station to step up voltage for long distance transmission. In substations, transformers step down voltage for safe distribution to consumers. In domestic applications, transformers are used in adapters, chargers, electronic devices. Transformers are widely used in audio systems, amplifiers, and communication equipment. They provide impedance matching, voltage isolation, and noise reduction, which improves signal quality and system performance. They are also used in audio systems, instrumentation, welding, and isolation purposes. Thus, the transformer plays a crucial role in both high power and low power applications. In conclusion, the transformer is one of the most important device in electrical engineering. Its ability to efficiently transfer power at different voltage levels makes modern power system possible. Understanding transformer operation helps student grasp advanced topics such as electrical machines and power system. These topics are come under one by one. Thank you.